lying, still not lying. Okay, so here it says, a sports car priced at $60,000. So that's my I, my initial. Depreciates. So I know I'm going to have to use the formula, which is 1 minus I, correct? It depreciates by 40%, so my little I is going to be 0.14. How long will it take to depreciate to $18,000? So that's my final. And how long means what? They're looking for N. We agree? So we're going to fill in final, which is 18,000, equals initial, which is 60,000. 1 minus 0.14 because it says depreciates, and then an N. Now what I tell you have to do if you have the final and initial, your very first thing you should always do, every single time, divide over the initial. So we divide over the 60,000, and what do we get? You take a 6 out of both, so we get 310, 3 over 10, equals 0.86 to the N. We agree? Now, if this was a written response, you have to do it algebraically. If this was in a multiple choice, you could y1, y2 right now and try and figure it out. You just have to make sure that your x max is big enough, because sometimes it fights you and it's like, I can't do this. I cannot find where it is. Error, dim mismatch, blah, blah, blah. So we're going to convert it, though, because it's actually easy to convert at this point. So if it's an exponential and I only have one exponent, I can convert to a log every time. If I have 2 exponents, I can't convert. So 1 exponent I can convert to a log because I need 3 pieces of information to convert, and I have 3 pieces of information. So I go log. Now the base of my exponent becomes the base of my log, so I get 0.86. Currently n is with it, so it can't stay with it, because if what's friends doesn't stay friends. So we get 3 over 10 equals n. Everyone typing it in. So if you have the old calculators, you're going log 3 over 10 divided by log 0.86. If you have the new calculators, you can use the math button. Now, it's 7.98, so we're going to round to 8. But what if it was 7.18? And I want, how long will it take to depreciate to below 18,000? If it was 7.1, would I say 7? No, because it wouldn't be below 18,000. It would be a bit above, right? So I'd still have to go to 8. Even if it was 7.1. This one just rounded nicely. So n equals 8 years. And if this is a written response, we would write ourselves a little sentence, and we would say, it takes 8 years for the sports car price $60,000 to depreciate to $18,000, below $18,000, right? Just rewrite the sentence. The next one, a radioactive isotope has a half-life, doubling, tripling, screens. We have to use that formula with the R. So it has a half-life. So R equals a half. This is the only formula you're actually given on your formula sheet, just so you know, except it's not labeled the same. Y equals A, B, T over P. Formula that you're given in. Throw the K formula. So, it has a half-life of 45 minutes. Remember, this is key. So if you're on your phones, you're not listening. If it says half-life of 45 minutes, they gave you P. If they say it doubles every 20, it triples every 40, they gave you the period. They gave you how long it takes. So if it comes right after the word half, double, or triple, it is P, just so you know. If the word half, double, or triple is in your question at the end, you're missing P. That's the way to tell. So if they give you the half-life is this, if it follows the number of the time follows right after half-life, double, or triple, they gave you P. If they say determine the half-life, blah, 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 and that's in the question, then they didn't give you P. Make sense? Follows directly after half-life, doubling, or tripling, it's P, because I can say this halves every 45 minutes. So in 45 minutes, it's halving. In 45 minutes, it's halving. In 45 minutes, it's halving. If I can explain that, that's the period. That's how long it takes to halve. So they gave me P. How long will it take 480 milligrams to decay to 15? So they gave me I and they gave me F. And they want to know how long to reach final. How long to reach final is T. So we're going to get final, which is 15, equals initial, which is 480. R, 1/2, to the T over P, T over 45. What do I do when I have initial and final? I divide them out, and I do not use rounded decimals. So I'm going to go 15 divided by 480. And it is a finite decimal, so I could write it down. or I'm just going to reduce it to 1 over 32. It doesn't matter what you use because this decimal actually stops. I have a tickle. I don't know what's going on. Okay, so what do we do next? After your final and your initial are divided, and you're still looking for an exponent, what do? Convert to a log every single time. So we're going to go log base 1/2. Because the base of my exponent becomes base of my log. What's with it doesn't stay with it, and I need something beside the log. So what's going to be beside it? 1 over 32, and it's going to equal t over 45. And how do I get the 45 by itself, or the t by itself? Times by the 45. So I'm going to get 45 log 0.5 or 1/2. And I get 225. 225 what? Minutes. Because whatever P is in, T is in, whatever T is in, P is in. They're the same units. So it's going to take 225 minutes for the radioactive isotope to go from 480 milligrams to decay to 15. Right? Okay, this one I ask you to solve algebraically. When you have one log, we're going to do tomorrow where you have more than one log. You're going to have 2 logs. When you have one log, you can convert to exponential. And how do you know when to do it? When you don't know the x beside the log or the x in the base. So when we have one log and we don't know if the x is here or here, we convert to exponential every single time. However, to convert to exponential or to logs back and forth, I can only have 3 pieces of information. I currently have 4. What do I move? It's 4 first, right? Some people bring it up as the exponent, which can work, or because these are nice full numbers, I can divide by the 4. So I get 1/2 equals, and I should not be working out of the question, but I just did. Log base 6 of x plus 2. Now I convert, I have 3 pieces, correct? So the base of my log becomes the base of my exponent. Base of my exponent means I need an exponent. What's my exponent going to be? 1/2, because what's with it can't stay with it, right, when they convert? So it's going to be 1/2 equals x plus 2, and then I'm going to subtract 2, which is the square root of 6 minus 2. So it's 0.449. Now remember, you can check these. You can take that and put it in this side. So you can go 4 log base 6 of the whole decimal plus 2, and hit enter. So everyone's going to do that on the main screen. So type this one in. Type in 6 to the 1/2 minus 2 and get an answer. Every single person's going to do that. On your main screen, you're going to go 6 to the 1/2 minus 2. And you get a decimal. 0.4494897428, right? Now on that same main screen, we're going to type it into this. We're going to type in 4 log base 6, and you can take the answer. You can go steal it from above, or you can take it, but you're going to put it in here. So you're going to go 4 log base 6, and then I'm going to go steal my answer from above and hit enter, and then go plus 2. And hopefully I get 2, because what's on this side? 2. Did you get 2? Then you know you're right. You're happy. You move on. You can check every solving question. Doesn't matter what unit we're in math. If it says solve, you're going to solve and get what a variable equals. You can take that variable, you can plug it back in and see if it actually matches. Right? Every single time. Okay, this one I said I'm going to do this till you guys stop messing it up. What did I set you up for? Not failure. No, not disappointment. I set you up for not moving that 1/2 to a 2 is what that is not mocking or failure or whatever you just all said. Okay, so that 1/2 needs to be a 2. Why? Because you can only compare exponential functions with the same base, and that base doesn't appear anywhere in our comments, right? Nowhere. So the first thing you're going to have to do, well, you can add the 3 over, so we can go y equals -3, but this 1/2 is going to actually have to be 2 to the -1, 4x minus 1. plus 3. And then what do I have to do still? Take out the 4. So what's going to join this negative 1? A 4. So I'm going to take out a 4, so I'm going to actually have negative 4. And when I take a 4 out of negative 1, what do I get? Yeah, minus a quarter. And then plus 3. If that's hard for you to do, don't do it this way. Go like this. Go 1/2. So I would do this. Y minus 3 equals negative 3, 1/2. Take my 4 out, and then I'm left with x minus a quarter, right? Then change it. Y equals negative 3, 2 to the negative 1. So the negative 1 is just going to join the 4. Like, you take the 4 out first if it's confusing the other way. Still end up with the same answers, right? Okay, it's an exponential function. Exponential function says horizontal asymptotes on the x-axis if and only if there's no translation, vertically or vertically. So what is this? It's still a horizontal asymptote. What's the only thing that can move your horizontal asymptote of y equals 0 normally? Vertical translation. What's my vertical translation? 3 up. So what's my horizontal asymptote going to be at? Y equals 3. You have to write horizontal or vertical, just so you know. In this case, it's horizontal. And you have to write y equals or x equals. You can't just write 3. It's not going to go over well for you. What's the domain of every single exponential function unless it's a word problem? X and M of the reals. And why do I say unless it's a word problem? Because if the word problem talks about time, you can't have XER. It would start at time 0 and onwards, right? So my domain is x such that x and M of the reals, or negative infinity to positive infinity in interval notation. My range is all based on the y's of what's happening to the y's. We agree? So what's happening to my y's? Well, that affects my y's. I would draw a y with it. So my range is always going to be greater than or less than the asymptote, correct? The asymptote is 3. We agree? Is it going to be greater or less? Less. Why? Yeah, there's a reflection. And there's a reflection in the x-axis because there's a negative with my y. Now, some people are like, I don't know if there's a negative with my x, does it change it? Well, x stuff doesn't affect range. So, no, it wouldn't change it, right? Y stuff affects range. X stuff affects domain. Range, domain. That's it. So this range is going to be y such that y is not greater than 3. It's actually less than 3 because it's dropped YER. Why isn't it equal to? Because your asymptote's there, you can't have it equal to it. There's actually a dashed line which not allows information to be on it, right? And in interval notation, it's going to be negative infinity to 3 round bracket. And it's round because it's not equal to. And then mapping notation, you have to go x, y, brackets. Some of you guys do not put in brackets. That ain't a coordinate if there's no brackets. X, y, and then arrow. It has to be in this format or it's not mapping notation. Now what happens to my x? I'm going to multiply by negative a quarter because it always flips. X, and then it's minus a quarter, so I'm going to add a quarter. My y's, I'm going to multiply by negative 3y and add 3. If you're still someone who's struggling with transformations, come in. We'll practice till you're not struggling anymore. Okay, number 5. I did not teach you how to do this exact question, but I see stuff like this all the time appear on tests, diplomas, everywhere. It uses the knowledge from yesterday's lesson, okay? Now, how do I spot these? Well, it'll say, if I have log base a of 2, I can replace it with an x. If I have log base a of 3, I can replace it with a y. We agree? That's what that's saying. Yes? Well, I have log base a of 72. And then they're like, what the crap is that? That's not a 2 or a 3. This is stupid. Can 72 be broken down into 2's and 3's, though? Yeah? 72 is 8 times 9, is it not? How many 2's make up 8? Nope. 3. 2 times 2 times 2 is 8. How many 3's make up 9?
You've been adding.
Oh, true. If you add them, that would work. But we're multiplying because when we multiply things with a single log, we can actually expand them, correct? Multiplication can be expanded by plus or minus signs. So here, We want 72 to be in 2s and 3s. And why do I want it in 2s and 3s? Because that's what they gave me with 2s and 3s. So some people are like, I don't know what they wanted in. They tell you what they wanted in. You make it in there. Okay? So 72 is the same as going 2 times 2 times 2 times 3 times 3. Now, why would I do that? Because if I have things multiplied, I can separate them with addition. Right, Liam? Yeah, totally. Totally. Cool. On your phone. I know I'm not that interesting, but let's go, Turbo. Okay. Cool.
I was Turbo.
Who invited this guy?
I'll leave.
You asked me to leave. Do it. Go for it.
I didn't ask him to leave. I'm just not going to ask him to stay. There's just options. I'm not paying him to be here, so there's options for him, right? That does not shock me. All right. Let's turn 72 into 2 times 2 times 2 times 3 times 3. So we get log base A of 2 times 2 times 2 times 3 times 3 times a to the 4. Now what can I do when I have a whole bunch of multiplications? I can use the multiplication rule and separate them with what? Single logs by addition. Remember, I told you guys you're really good at taking additions and subtractions and putting them together as a single log, but you're kind of terrible at remembering that you can take them back apart, right? So you can put them together, but kind of forget that you can take them apart. So we want to get past that point. We want to remember, hey, I can take them apart. And how can we take them apart? Remember I told you if you put these little dots, sometimes they give you like a little remembering why am I putting the dots? Oh, right, I can separate them by addition. Because I have nothing in my denominator, which they could do. They could have given me the A4 in the denominator. I would just have to go minus A4, right? Minus log base A of A4. So we're going to separate these all out. So we're going to get log base A of 2 plus log base A of 2 plus log base A of 2 plus log base A of 3 plus log base A of 3 plus log base A of 4. A of A to the 4, sorry. So what do we know? When we get a log base A of 2, what can it be? What does it say? Log base A of 2, we can replace with x. Log base A of 3, we can replace with y. So let's do that. So this is x plus x plus x plus y plus y plus, what is this? We did this yesterday, log a to the 4. It's just 4. Log a to the 4 is just 4. Now why is that? If I have log a to the 4, remember I can drop that 4 in front? And that's multiplied by log a to the a, and log a to the a is just 1. So it's 4. So remember if you say a to the 4, it's 4. So my answer is going to be x plus x plus x, so 3x plus 2y plus 4. Now I'm going to get you to take out some paper because we're going to do some solving. We're doing here solving exponential equations. We have learnt 2 ways already to do this. The hardest part is to figure out what the heck when you see something, what do you do? So we're going to go through, when you see a solving exponential equation, what do you do? The first 2 we've already done before, but I'm just going to go through them again. So what does solving an exponential equation look like? It'll say solve, and then you're going to have variables in the exponent. Okay, that's how you know it's an exponential equation. It has a variable exponent. So let's look at the first type. Type 1. There are 3 types, and you need to know what you do with each type. Type 1, common base. We've already done this. We've done this over and over and over and over. What the heck does common base mean? It means I can give you a whole bunch of exponents, variable exponents. I can give you 3, I can give you 4, I can give you 2, I can give you 1, I can give you any. The key part to the common base is that you can make them all be the same base. So base 2 or base 3 or base 4 or base 5, whatever it may be, right? But I can give you more than one exponent. I always, when they say solve and it's an exponential equation where it has a variable exponent, I always look for common base first. Because if I can do that, I'm going to. So what am I going to do? I'm going to make something that has all base 3. So I'm going to say solve. So that's the first thing you're going to notice. It's going to say solve. And then I'm going to give you something with variable exponents. So try this one out. So we're going to get 9 to the 2x plus 1 over 3 times 27 to the x minus 1 equals 81 to the x plus 3. I have 3 variable exponents here, don't I? I have 3. 3. So I'm going to first look and say, can I do common base? What base can I make them all be? 3. You go ahead and try. We've done this over and over and over. This 3 down here is 3 to the what? 1. Don't forget to put a 1 on it. Do not go 3 times 27. That is illegal in all places in this world and Mars. So this is 3 to the 1. This is 3 to the 3. It is not 81. That is bad news bears. Do not do that. Try this question. Okay. So I'm going to make them all be base 3. Shh. I'm going to make this one is 3 squared to the 2x plus 1. This one is 3 to the 1. This one is 3 to the 3 to the x minus 1. 81 is 3 to the 4 to the x plus 3. So our first step is to always get them to be the same base. Our second step is to distribute that new exponent we just got into the other exponents. So we're going to get 3 to the 4x plus 2 over 3 to the 1 times 3 to the 3x minus 3 equals 3 to the 4x plus 12. I still can't drop my bases off. Don't go dropping your base off. So many people drop their bases off. You can only drop your bases off when you have 3 to the something equals 3 to the something. Do I currently have that? No, I have 3 to the something over 3 to the something times 3 to the something. Like there's too many 3's going on this side. So my first thing I need to do is put that denominator together. I have 2 bases, 2 exponents. What am I going to do with those exponents? Add. So I have 3 to the 4x plus 2 over 3 to the 3x. And then minus 3 plus 1 is minus 2 equals 3 to the 4x plus 2. Do you want for plus 12? Do you want to know where the common error happens? Right here. Well, it sometimes happens above because no one has a clue what they're doing. But when they actually know what they're doing, this is the common error. Because you want to know why it's common error? Everyone drops off the 3's and goes 4x plus 2 divided by 3x minus 2 equals. And they will have that answer there and it will be wrong. Yeah?
Why does the minus 3 on the bottom exponent become, oh, because you're adding it. Got it.
Add the 1. Yeah, and if you forget that exponent, if you forget to write the 1 on the 3, you'll forget to put them together. That's one common error. Second error, if we get to this point, people will just drop the 3's off. I can only drop the 3's off if I have 3 to an exponent equals 3 to an exponent. Do I currently have that? No. This side's still a problem. What do I have to do with this side? The side of the left side. Subtract. So I'm going to get 3 to the 4x minus 3x is x. 2 minus a minus 2 is actually plus 4. Look how many steps we had to do till we were finally to this point. Now we're at the point where we have 3 to the something equals 3 to the something. Do you agree? Now and only now can I drop those exponents off because it makes sense. If these are equal, then this right here and this right here should be equal. If that's an equal, if that's a true statement, this exponent has to equal that exponent. We agree? So we have x plus 4 equals 4x plus 12. Subtract x And then I get 4 equals 3x plus 12. Subtract 12. Negative 8 equals 3x. Divide by 3. X equals negative 8 over 3. Now I could take the negative 8 over 3, not the rounded negative 8 over 3, so that negative 8 over 3, and I could plug it in for all the x's here, the x here, get a decimal, the x here, get a decimal, and those decimals should match. We agree? They should match. If they don't match, you made a mistake. The other thing I told you could do is you could y1 your original, y2 your other side, and then go second trace 5, enter, 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 and they'll give you negative 8 over 3. So if it was a numeric response or multiple choice, you wouldn't even have to do the math, technically. But I always would to check. So that's type 1. Type 1, you can make a common base. We also learned type 2. Type 2 is when you have one exponent. So type 1 is when you can make common base. Type 2 is when you have one variable exponent. That's all you can have. If you have more than one, this option is out. The option that we do here is convert to a log. That's what we're going to do. We're going to convert to a logarithm. But the only way we can do that is if we have an exponential equation with one exponent, one variable exponent. That's it. If I have 2, I'm done. I can't do this type. It's out. I can only convert to a log if I have one variable exponent, like all my word problems. All my word problems have one variable exponent. That's why I can use converting to a log every single time. So, I say solve 3 to the x plus 2 equals 6. I can't make a common base. If I could, that's the route I would go. Can't make a common base. So then I say, one variable exponent. Only one. If I had 2, this is done. I can't do this. I have 1. So what do I do when I have 1? I immediately make it so that I have 3 pieces of information, because that's all I can have in order to convert to a log. If I have more than 3, I have to do something first. So I have 3 pieces of information. I have one variable exponent right here. I can convert to a log. Do you see the difference? So you have to see something and know what to do. See something and know what to do. So when I'm asked to solve exponential, I look for common base first. If that's not an option, I look if it has one exponent. If it has one exponent, I convert it to a log. If it has more than one exponent, I'm going to do what we're going to learn today. That's it. You see, you have to know what to do. It's what you have to do. If not, the test's really hard because you don't know where to go. So we're going to go log base what? Base 3, because the base of my exponent becomes base of my log. What goes beside it? 6, and it's going to equal x plus 2. And then what am I going to do? Minus 2 from both sides. So I get x equals log base 3 of 6 minus 2. And sometimes that's just the answer on a multiple choice. They don't even work it down to a decimal. Sometimes they might say in the form, because guess what? Could you not just y1, y2 this? Yeah, so they might say solve this into the form x equals log 3a minus b. Determine the values of a and b. So they force you to do it algebraically. Right? Okay. This would work out to negative 0.36907246466, which I'm going to say negative 0.4. So that's type 2, correct? We've learned both of these. Type 1, common base. That's what I'm always going to look for, no matter how many variable exponents there are. Because if I can do that, I'm going to do it. Type 2, I can only use if I have one variable exponent. Type 3, I'm going to have to use where? Can't make common base, more than one exponent. Right? And then I'm forced to use the third method because I can't use common base and I can't use type 2. So I have to use type 3. So type 3 is what we're learning today. Type 3, you use when can't common base and more than one variable exponent. That's type 3. So I can't common base and I have more than one variable exponent. The most basic question I could ask is this. Solve. 3 to the x plus 4 equals 4. If I do this, I can solve the type 2. Do you agree? If I do this, I can solve the type 2. So what are they going to do? 2x plus 1. Another exponent. Right? Two variable exponents, and I can't make a common base. I have to do type 3. You see that? I have a 3 and a 4. Can't make common base. I have 2 exponents. Can't do type 2. Type 1's out. Type 2's out. I have type 3. It's the only option I have. So how do we do this? This is a long, big kahuna question. You're going to need space. It is not a hard question. It's a lot of steps. So you need to know how to do them. Not done in 30-2. And in 30-2, when you had 2 bases with 2 variable exponents, all they could make you do was while and wait. 30-1 is not the same. So here's our steps. So we know we can't make common base. Type 1's out. We know we can't do type 2 because there's 2 variable exponents. We have to do type 3. What is type 3? Your first step is to log base 10 both sides. And why the heck am I doing that? Because I need to get those variables to get the heck out of my exponents. Correct? I need those variables to get down. Because then I can do some math with them. We agree? With them up there, I can't do it. If I log base 10 both sides, what's the rule with logs? I can use power rule. What's the rule with logs? I can take my exponents and I can drop them in front, can't I? I fixed my problem. My problem with this question is those exponents sitting up in the exponent. But if I log base 10 both sides, my exponents can drop down, and my problem is gone. We agree? So let's log base 10 both sides. And I log base 10 because I used to not log base 10 for the first 6 years I taught this. And then people tried dropping the 3 and the 4 in the base spot of the log. Because you could just log both sides. Because remember, base 10 you don't have to write. The moment I didn't put the base 10s in, you guys in general, not you guys 6 years ago, would take that 3 and that 4 and drop it into the base because you're like, something must be there, right? So in order to get that to stop happening, I log base 10. The 10 fills that spot, and you won't shove your number into there. Okay? So we're going to go log base 10. And remember I told you it's better if you understand why you're doing something than if you memorize. If you understand why you're doing something, you're not memorizing steps, you won't forget the steps, right? So why am I log base 10ing both sides here? Because then I can use the power rule to take that exponent and drop it in front. That's why I'm log base 10 both sides. And I can do it because I can do whatever I want to one side as long as I do it to the other side of the equation. You're taught that since little, since junior high. If I do it to one side, I just have to do it to the other, and I haven't changed anything. So I'm going to do log base 10 of 3 to the x plus 4. X plus 4 is still my exponent. Log base 10 of 4 to the 2x plus 1. Now, why the heck did I log base 10? Because now I can take those exponents and I can do what with them? I can drop them in front because that's a rule with logs, correct? Then is my problem gone? Yeah, now I have a whole bunch of math to do, but my problem is fixed. Now I just got to work with it. So, step 2 is drop the exponent in front. That's why we had to get it into a log. Because if we didn't have it in a log, we couldn't do that. Make sure you put in brackets. So we're going to get x plus 4 log base 10 of 3 equals 2x plus 1 log base 10 of 4. Does everyone understand what we did so far? So you log base 10 both sides so that you take the exponent, you can drop it in front. Does that make sense? If it makes sense, it will make it easier for you to do this question. Now, I have my exponents in brackets. Do you see that? If I want to get rid of brackets, what do I always have to do? If I want to get rid of brackets, what do I have to do? Starts with a D, rhymes with distribute. Distribute. Good job. So it's distribute. So step 3 is going to be distribute my brackets. That's why you put those in brackets. So we're going to go like this, and then like this. So we're going to get x log base 10 of 3. Plus 4 log base 10 of 3 equals 2x log base 10 of 4 plus 1 log base 10 of 4. Do I have to really write the 1? No. So first step, log base 10 both sides. Second step, bring your exponent down. Third step, distribute. Fourth step is to get all your x's to one side, everything with an x to one side. I always get on my left. And then anything without an x to the right. Move all terms with an x to the left and other terms to the right. So this one has an x, this one has an x. I'm going to move them to the left. One's already on the left. Correct? This one doesn't have an x, this one doesn't have an x. I'm going to move them to the right. You see what I'm saying? So the green ones are going to move to the left, the red ones are going to move to the right. Could I do the opposite? Could I move the x's to the left, to the right, and the yes. Just get the x on one side and everything else on the other. So how do I move? Adding or subtracting? So this one here is a 2x log base 10 of 4. I'm going to subtract 2x log base 10 of 4. So on the left, I'm going to get x log base 10 of 3 minus 2x log base 10 of 4. And it's going to equal, now I need to move this one over to the side, so I'm going to minus 4 log base 10 of 3. So I'm going to get log base 10 of 4, which I could put plus 1 log base 10 of 4. It's the same thing. Log base 10 of 4 minus 4 log base 10 of 3. Why the heck would I get x's together? Then I'll be able to GCF an x out. I'll be able to solve for it. If both those terms have x's, and look, they're all multiplied. X times log 3, 2 times x times log 4, they're all multiplied by those things, right? If you get the x's together, you can take an x out. That's the reason why you're going to get the x's together. So your fifth step is to GCF an x out. So if I take an x out of this side, I put a bracket because my GCF I'm left with a bracket. When I take an x out of x log base 10 of 3, I'm just left with a log base 10 of 3. When I take an x out of this, negative 2x log base 10 of 4, I'm just left with minus 2 log base 10 of 4. I'm going to write the sixth step, but I hope I don't even need to. How do I get x by itself? Divide that ugly looking bracket over, right? Because it's just being multiplied by the x. and type it in your calculator. Now you guys, do I actually have to use the math button? It's log base 10. Do I have to go log base 10? Can I just press the log button? Yes, this one's easily as good for the older calculators as the new one. You can just use the log button. But if you're not using alpha y equals, make sure you type in brackets. So you're going to go log 4 minus 4 log 3 in brackets, divided by in brackets, log 3 minus 2 log 4. I don't need to put the base 10, right? Because base 10 is just assumed on the log. Everyone's typing it in. I get 1.8. Hopefully you get 1.8 as well. So your first step is to log base 10 both sides so that you can take the exponents and drop them in front. Once the exponents are in front, in brackets, you distribute. Once you've distributed, you get all the x's on the left, everything else without an x on the right. Why do you get the x's together? So you can take a GCF of an x out. And then you can divide it over. It should make sense to you. If you're just memorizing, it scares me because people who memorize forget. You get a little stressed out and things fall out, right? It's just what happens. This should be understanding. You log base 10 both sides so that you can take the exponents and drop them in front because we just learned that rule yesterday. Then you can distribute because there's brackets. And when you brackets, you get to distribute. Put your x's to one side, not x to the other. Take out GCF from x, divide it over. It should make sense to you. Okay? You're going to try this one. Six to the 3x plus 1 equals 8 to the x plus 3. But you can y1, y2 it, right? And get it quick. So we get log base 10 of 6 to the 3x plus 1 equals log base 10 of 8 to the x plus 3. Drop the exponents in front with brackets. You remember to distribute. 3x plus 1 log base 10 of 6 equals x plus 3 log base 10 of 8. Distribute. So we get 3x log base 10 of 6 plus 1 log base 10 of 6 equals x log base 10 of 8 plus 3 log base 10 of 8. And I'm going to minus my x log base 10 of 8 over. Minus my log base 10 of 6 over. So I'm going to get 3x log base 10 of 6 minus x log base 10 of 8. So the x's are together. 3 log base 10 of 8 minus log base 10 of 6. Take an x out. Then I'm left with 3 log base 10 of 6 minus log base 10 of 8 equals divide it over. Get 3 log 8 minus log 6 divided by bracket 3 log 6 minus log 8. 1.35. Now, if you put the rounded decimal in for x, are both sides going to match? No, it'd be a little off, because that's not actually the answer, right? The rounded decimal is not the answer. If they ask us round, that is the answer, but if you're going to check it, you check the whole thing, right? Okay, there's not a ton of questions on this one, but there are a few to practice. And there's one where if I add an extra number, it makes you have one extra step, but I'm not doing that today. I want you to just practice these ones. I'm not overwhelming you with that one. So it's page 413, 7A to C. If you worked right now, you do have 5 minutes. If you work speedily, you can be done with 3. Done your homework.